Oh, welcome back, students. Today we'll be starting with the problems on moment of inertia. This is a very important problem. As you can see, it has been repeatedly asked in the video question paper. That was long time back in 2004. But the concept of moment of inertia is very well explained in this problem. They are asking to determine the moment of inertia of the plane lamina as shown in the figure about the axis xx. The axis is already defined in the problem, right? Earlier, otherwise, we used to locate the whole lamina in the first quadrant, but here it is so the xx axis is already been defined. About this axis, we are supposed to calculate the moment of inertia. Okay, very simple problem and straight going problem, right? I can apply the perpendicular axis theorem directly. So I'll read out the figure. So you find what is the composition of the lamina? The lamina consists of one triangle, one rectangle, and a circle. And a circle, right? Here is a circle, and you find this circle is at a center of 75 mm from both the end. So this is 75, this is 75, right? And the width of the rectangle is 50 and 50. 50 mm here and 50 mm here. Then you find height of the triangle as 125, 120. The height of the triangle 120 mm, and the radius of the circle is 25 mm. The radius is 25 mm. Okay. They have asked about the axis xx. The x-axis is located at a place where it is connecting the triangle and the rectangle, right? In common problems of moment of inertia, usually the axis will not be defined about which axis. They are directly asked to locate the moment of, to calculate the moment of inertia about the centroidal axis. That is a common problem. But in a problem wherein they have defined the x-axis and they have asked us to calculate the moment of inertia, then straight away we can go to the calculation of moment of inertia. No need of calculating the centroid. Centroid calculation is not required here. Okay, so how to solve such a problem? So there are three things, uh, three components which can be seen here. One is a rectangle, then one is a circle, a triangle, and the other one is a circle. So I want the moment of inertia. So to get the moment of inertia of this lamina, I should add rectangle and triangle and subtract the circle, because this is the area what I'm looking for it. I'm looking for this area. Okay, I'll erase the content once. Yeah, I'll represent using some other color. So I want this area. The moment of inertia of the lamina, of this lamina. So it will be one triangle, one rectangle, and one circle. Okay. So how to go about? I'll be apply parallel axis theorem. Perpendicular axis theorem. So which says that Ixx, or moment of inertia at any point, equals to sum of the moment of inertia of individual or self plus a summation of the area into, when I'm talking about xx, the perpendicular distance has to be y. So y minus y by the whole square. Okay. Here I'll be writing Ixx as, first one is I'm taking the rectangle. Rectangle as the first lamina, second lamina is a triangle, third lamina is a circle. So for the moment of inertia of a rectangle, it is BD cube by 12. Okay, where B is the width, D is the depth. Okay, plus the area B into D. Okay, then what is y minus y bar square here? We don't have the value of y or y bar. So what should I do? Actually, y minus y bar square is a square the perpendicular distance. Square the perpendicular distance. Perpendicular distance from where to where? Perpendicular distance is from the centroid. From the centroid to the axis. So now for example, I'll redraw the diagram of the rectangle there. The rectangle centroid is here, right? At a height of 75. Correct? Where is the axis? The axis is here. The axis is here. So what is the distance between the centroid of the rectangle to the axis? 75. Directly I can write it as 75. Okay. Plus, what is the next? Next lamina. I found it as a triangle. The next lamina is a triangle. For a triangle, what is the moment of inertia about the centroidal axis, x axis? It is BHQ by 36. Okay. BHQ by 36 plus, what is B here? B is the width of the triangle. What is H? H is the height of the triangle. Plus the area of the triangle, half into base into height. Okay. Now what is y minus y bar square here? So it is a distance. It is a distance. The centroidal distance to the, it is the centroid. This is the centroid of the rectangle. Sorry, triangle, and this is the axis. What is the distance here? You can see it is 1 by third of the height. You call it as 1/3 of h the square. Okay. And the last one is minus. We have to subtract the circle. For circle, what is the moment of inertia? Pi r square by, 1 second, I'll check with that. Pi r to the power of 4, pi r to the power of d. Yeah, pi r to the power of 4 by 4. Okay, so this will be minus pi r to the power of 4 by 4. Okay, moment of inertia. So in the diagram, you can see where is the centroid of the circle here at the center, which is at a distance of what? From to the axis to the centroid at a distance of 75 mm. So it will be the area of the circle is pi r square, okay, into the distance is 75 square. Now I'll be substituting the values of each. Ixx is equal to BDQ by 12. What is B? I'll take the diagram from here. So what is B here? B is 100. B is 100. BDQ by D is how much? 150. It is not substituting. Is BDQ by 12 plus 100 into the area of the rectangle into, sorry, not square, area into 75 square plus what is the triangle? B is again 100, H is BHQ by 36 plus area half into 100 into 120 into what is the perpendicular distance? 1/3 of H, 1/3 of 120, right? Minus the area of the circle, sorry, moment of inertia of the circle to the power of 4 by 4 minus the area pi r square by pi r square into square the distance. Yeah, I forgot here the square. And here it will be, what is the distance? Perpendicular distance. So therefore, upon all substituting and calculating, the final answer you'll end up with 1.155 into 10 power 8. This is the final answer what you'll be getting upon calculation. Okay. Okay, students. Okay, with this 1.188 into 10 power 55, sorry, 55 into 10 power 8 mm to the power of 4. The unit here should be mm to the power of 4. Okay, fine. With this, thank you all. I'll end the session.